In this video, let us dive right into a light introduction to the idea of recursion and what the recursive formula is. Recursion formula is a formula by which each term of a sequence is generated from the preceding term or terms. For example, the Fibonacci sequence has the numbers 1, 1, 2, 3, 5, 8, 13, and so on. Can you see the pattern? Each term, starting from the third term, is an addition of its previous two terms. So as we can see, 2 is an addition of 1 and 1. Also 3 is the addition of 1 and 2. And 5 is the addition of 2 and 3. As well, 8 is the addition of 3 and 5, and so on and so forth. Good. So how can we write down our recursive formula? Well, let's take a look at another pattern and try to write it down as a recursive formula. Here we have 4, 8, 12, 16, and 20. Notice how we can easily represent this in the form of this. This, however, is not a recursive way to represent the following. This form starts with the first term and then calculates the total difference between that first term and the term we're looking for. Instead, a recursive formula should be using the function of a previous term. So in this case, we would write down the first term as f of 1 equals 4, and then we would construct the following formula. So notice how if we had f of 2, then we would get f of 2 minus 1, which equals f of 1 plus 4. And since f of 1 is equal to 4, f of 2 would be equal to 8. So again, this is the recursive way to represent this sequence. Notice how we wrote down the first expression, since the formula always requires the previous, or shall I say the n minus 1th, result in order to get the value of the nth term. So, bringing back the Fibonacci sequence, if we wanted to represent this in a recursive formula, then we would have to write down the representation of the first and second terms. In this example, we're using the letter t, so here is our recursive formula. What we are saying here is that the result of any term is the addition of the term immediately before it and the term that's before n minus 1, which would be n minus 2. So let's just try a quick example and plug 3 into the formula to solve for the next term. If we plug 3 into the formula, we get the following. Simplifying gives us t of 3 equals t of 2 plus t of 1. Here, we are given what t of 1 and t of 2 are equal, so let's replace them with their values. Finally, we get our final value of t of 3 equals 2. And now that we know the value of t of 3, we can continue on and solve for the value of t of 4, and so on.